Okay, in 9.3, we're talking about composite figures, and what we're going to focus on, excuse me, is using the area addition postulate to find the areas of composite figures. And what composite figures are is when we have more than one shape, a simple shape. So let's say we had a square and we had a triangle. We wanted to figure out what the area of this composite figure is. So composite figure is when we have two or more simple shapes that that make up this shape. If I just give you this shape, we don't know exactly what formula we could use. It's not a trapezoid, it's not a parallelogram, it's not a circle, it's not a triangle. So what we're going to do is we're going to split it up into two different pieces that we do know the area formula for. And if we add up the area of this triangle with the area of this square, we're going to get the area of the whole composite figure. And that's what the area addition postulate states. So some examples would be like this one. I don't know what this red thing is. Let me take it away. We have a semicircle, so a half circle, and we have a trapezoid. So the first thing you're going to have to be able to do is figure out what shapes the composite figure is being made of. And then once you have those two shapes, you know the formula is to find the area. For a half circle, you would take pi r squared, which is the area of a circle, and divide it by 2. And in this picture, we know that the diameter of the circle is 20, so that means that the radius has to be 10. So when you plug 10 in, you're going to get 100 pi. 100 pi divided by 2 would be 50 pi. So that would be the area of the circle. And then if they want it to be rounded to the nearest tenths, so you'd have to actually multiply 50 times pi. And then the other shape would be the trapezoid. So you have to also remember that for the trapezoid, sorry, this is the area of this semicircle, 157.1. For the trapezoid, the formula is half of the height times the sum of the bases. So the bases, remember, are always the parallel sides. So that would be 20 and 32. And the height is always the perpendicular side, so that would be 14. So 14 divided by 2 is 7, 20 plus 32 is 52. When you multiply those together, you get 364. So now that we have found the area of the trapezoid and the area of the half circle, the last thing you have to do is add those two up to get the area of the whole composite figure. So 157.1. So to round it to the nearest tenth, your answer is 521.1 square millimeters. And that's your final answer. You're adding those two up. So again, the tricky part isn't necessarily memorizing the formulas, but sometimes it's what shapes makes up this composite figure. So this is a really complicated picture, but if you look, this yellow thing is a parallelogram. So the first thing we can find is the area of the parallelogram. And then the leftover part, that's just a triangle. So we have the area of a parallelogram, and we have the area of a triangle. And we know how to find both of those shapes, the area of those shapes. So area of the parallelogram is base times height, and you know that those are perpendicular. So the 5 and the 8 are perpendicular. That would be the base and the height of the parallelogram. So you get 40 feet squared. That's feet squared. And then for the triangle, you know that the formula is base times height divided by 2. And again, the base and the height are perpendicular, so we have 10 and 5 as our base and our height. Divide that by 2, and we get 25 square feet. And the very last thing you have to do is add up the two areas, and that gets you the composite area, the area of the composite figure. So 65 square feet. Again, sometimes it's just figuring out what kind of shape it is. This is another great one. If we split it up like this, which most people will do, we can figure out what the area of the rectangle is. And that's just base times height. So you would do the 37.5 and the 22.5. And that'll get you 843.75 square meters. So that's the area of this rectangle. And now you know that the other shape, well, that's a triangle. And you know that that formula is base times height divided by 2. Remember, the base and the height are always perpendicular to each other. And we know that this whole side is 75 and this part is 37.5. So if you subtract the two, you'll get that this is 37.5 as well. So that would be the base of our triangle. But what is the height? When you don't know what one of the sides are, you probably have to use Pythagorean's theorem. So we know one side is 37.5. We don't know what the height is, so I'm just going to put an h so that I remember that's what we're trying to solve for. So to do Pythagorean theorem, you have to square both numbers. So 37.5 squared is 1,406.25 plus h squared, and 62.5 squared is 3,906.25. When you subtract the two, you're going to get h squared equals, I'm pretty sure it's, yeah, 2,500. And then when you square root, you're going to get that h equals exactly 50 meters. So again, what we just solved for was this side of the triangle, and you know that it's 50 meters. And now that you know what the height is and you know what the base is, you can go back into this formula and figure out what the area of this triangle is. So multiply 50 times, 37.5, and then divide it by 2, and you get the area of the triangle is 937.5 square meters. And then the last thing you have to do is add those two up to get the composite area, or the area of the composite figure. So our final answer is 1,781.2 square meters. We're done. All right, so we might have to do Pythagorean theorem. Another type of question we could do is not where we're adding, but where we're subtracting. So as you can see, the bigger shape is the area of a triangle. So if we wanted to find out what the area of this whole triangle would be, you would do base times height divided by 2, and you know that 18 and 26 are your base and your height because they're perpendicular. So divide that by 2, and you get 234 square feet. So that would be the area of this whole triangle if we didn't have this half circle taken out of it. So the second thing you could do is find the area of this semicircle. So I'm only shading half of it. So we know that that's pi r squared divided by 2. And 9 represents the diameter. So the radius is going to be 4.5. So now we know that we're going to have to use pi times 4.5 squared divided by 2. And 4.5 squared is 20.25 times the pi is 63.6 divided by 2 is 31.8. So we get about 31.8. Again, it says round it to the nearest tenths. And then the last thing we have to do is we have to subtract this time because we're taking away that 31.8. So 234 minus that 31.8 gets us 202.2 square feet. And that's your final answer. Okay, so you're either adding or subtracting in composite figures. This one is the last one I'm going to do. I love this example because we know that the bigger shape is the area of a circle. So we know the diameter is 6, so r has to be 3, and we know that to find the area of a circle is pi r squared. So we know this is about 9 pi. The area is 9 pi. Second thing that we have to find is the area of the square, and we know that that's just base times height. And we're going to subtract these two areas. But the square, we don't know what the base and the height are. We're going to do this a lot in 2012. We know it's a square so that these sides are congruent to each other. So we could call these sides x. And we're going to use Pythagorean theorem to figure out what x is. So we have x squared plus x squared equals 6 squared. 1x squared plus 1x squared is 2x squared. And 6 squared is 36. So we have to divide both sides by 2, and we'll get x squared equals 18. And then we take the square root, and we get x equals radical 18. Now again, the x represents these side lengths. So we have radical 18 times radical 18. And when you multiply that out into your calculator, I want you to actually test it out and multiply these two things in your calculator. You should get just a plain old 18. And so the last thing you need to do is subtract these. So in your calculator, you can go 9 pi minus 18. And that'll get you your answer. So composite figures is a shape made up of two or more simple shapes, and you're either adding or subtracting to find the area.